33, here we go. So we're going to talk about two of the diagrams that we include with all our boilers, both a ladder and a schematic diagram. These are very, very common in all mechanical equipment, and each have a specific goal in helping us to understand what's going on. So let's take a look at them. So a ladder diagram is a graphic representation of the operational logic. Typically, they read these things left to right. There are two columns. One is the line, the other is the neutral, and there are a number of rungs crossing each one, indicating a particular logic function in that piece of equipment. And ladder diagrams, because it looks like a ladder. As I said, two vertical lines, power sources, and they represent components. And you'll see as you look at it, each rung is a single component and represents a circuit. Okay, I guess I just said this, so for those that are listening to me, then you don't have to read it, but so be it. I guess I've gone through this so many times that I'm anticipating myself.
Don't we all?
Right. Yeah. So a wiring diagram, on the other hand, is it's a visual representation of the actual physical connections and the layout of what's going on in that system, or a particular circuit, I guess, if it's less complicated. But it shows how the wires are interconnected, where what goes to what, and how the various components get connected into or sort of woven into the system. So the two of these together help us understand both how everything's connected and why, or the logic behind that connection, if you will. So it's not going to be a map in that it's telling you exactly where everything is, but it's going to be a map telling you how they relate to each other. So the connection of devices, of terminals, and from a service point of view, this is very, very useful because very typically they indicate both wire size, wire color, where they start, how they interact with each other. And so on one, it's telling you why it works this way or how it should be working, and on the other, it's telling you how it's connected to actually do that. These pictorial diagrams, they simplify the comprehension, and as I mentioned, they're going to show quite often wire size and color, depending on how intricate the diagram is. It's funny, I once upon a time, not to digress too much, but I had a BMW 2002, and I always thought, this is the greatest owner's manual. It's got a complete wiring diagram in it. It told me what size each wire was, what color it was. And after owning that car for a couple of years, I realized that they had to include it because it was always something you were tracing. So it was a joy and a frustration. The reason why these pictorial diagrams work in conjunction with a logic diagram is because it's very, very hard to understand how the logic works just from looking. I mean, you can see what's connected to what, but you can't necessarily see what the sort of logic is behind it or the order of that logic, which you are getting from a ladder diagram. In other words, as you trace the diagram down, you're seeing the order of operation as well as the logic behind it. So here's a very, very simple ladder diagram. You can see line on the left, neutral on the right. There's typically a main switch. And then what we're seeing here on the first rung is a normally open contact, which when closes will energize a circulator. Below that, you see a dotted line, which is typically what's used to delineate between line voltage and low voltage. And you're seeing a relatively universal symbol for a transformer in the midst of that. And below that, you're seeing a rung showing a thermostat, which would engage a relay or energize a coil. And that, so in a very simple line or logic diagram, that's how you would go about reading it. And then there's sort of, these are very, very common symbols, and typically these are the symbols that you're going to see in NTI diagrams. I went through all of our boilers and kind of picked out the common. So, you know, a convenience outlet, which we include on a number of our boilers, is indicated up there on the top left. And as you get down, you can see a normally closed safety, an air pressure switch, etc. The voltage transformer that we just talked about, symbol for a ground, a sensor, thermostat, etc. So these symbols are the ones that you're going to find in all of our boiler diagrams, both on the ladder and in the wiring diagram itself. And honestly, if you look at anybody's equipment, these are going to be very, very sort of universal symbols as well. So it's good to get familiar with them.
So Ted, a question came in while you have this up.
Sure.
What is the difference between a fuse and a thermal fuse?
A fuse is something that you can replace. In other words, you know, whether it's a spade fuse or an inline fuse. For instance, let's say in the TFTN, there are 3 of them, right? There's one inline fuse and a couple of spade fuses. A thermal fuse is something that typically is not replaceable. And for those of you that had experience with the TX, you'll recognize thermal fuse, because I'm sure it gave some of you fits at one time or another. When it failed, it meant that the heat exchanger was cooked and it had to be replaced.
So the regular fuse goes off by too much amperage draw, which could be caused by a short or a stuck rotor with too large of a pump, right?
Correct.
And the thermal fuse, and you referred to the TX, and I love that. At 480 degrees, it just broke the line and said, ha 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 ha, you've damaged the boiler.
Exactly.
Yeah.
Exactly. Yeah. So one is more of a, well, they're both safety devices, but one is user replaceable, the other is not.
Now, Ted, you said that the thermal fuse is not resettable, but we now have a thermal fuse on our plates, on our burner plates, on our fire tube boilers, and there appears to be a button in the middle. Is that not a button?
Well, you have to wait for, in that case, you have to wait for the temperature to drop. In other words, that's not like the TX where when it goes, everything's kaput. But in that case, it's temperature, in the one you're describing, temperature sensitive. When the temperature drops to a usable range, it can be reset.
Cool.
And then something else you run into all the time, but a normally open switch or contact and a normally closed switch or contact. And that's going to be at rest, so to speak, before things are energized. One would be an open, so when it gets energized, it closes. The other, when it gets energized, it opens.
Cool.
And as I said, if we're going to look at a number of ladder diagrams and wiring diagrams from NTI equipment, and you'll see all of these symbols appearing again and again and again.
So Ted, another comment that we should discuss.
Sure.
Which is, if you remember on the LX, there was a manifold limit, and that was a high limit, right? That was an over temperature limit. But we also have a high limit on other machines that it's not a thermal fuse, it's not anything, it's just a high limit, and that's what both of those are. Neither one of them are fuses, so you can't really call you can't really call a thermal fuse a high limit, right?
No, the thermal fuse is that's more of a safety device that, well, in particularly in the case like when I go back to the TX, that tells you that basically you've cooked that heat exchanger and made it unusable. In the case where you described after that, then the temperature drops, and that's actually closer to what you're just describing now. When the temperature drops back into a usable range that the machine recognizes, it can be reset.
Cool.
The other thing that I didn't show on here, but you can see an illustration of is over here on ground. When you see this little dot where wires connect or cross, that means they are connected. If wires cross without a dot on a diagram, it means there's no connection. They're just crossing each other. So where you see the dot is actually wires connected. And I guess I probably should have shown that as well, but there's the explanation for it. So here we're looking at a ladder diagram for both that serves actually for both all TFTN and the larger TRX. That's the 150 heat only, and both variants of the 199. That's how similar they are, that these diagrams serve for both of them. But you can see now in this case we've actually, the convention is a little bit reversed. We've started here at the bottom rather than at the top. But you have line on the left, neutral on the right. And interestingly enough, if you look at all of this, you can see what Steve was talking about earlier. There's absolutely no 24 volt that's accessible in these machines. It's lined into the junction box, which then feeds the various pumps. And there's the bus connection between the junction box and the main board. But again, all of this is line voltage coming out of here. There's absolutely no 24 volt accessible. Otherwise, you would see the transformer symbol. But so here, let's look at the wiring diagram for that same for those two same boilers, and you can see there. This is actually so from a troubleshooting point of view. The previous one tells you how things are connected, and this actually tells you where they're connected. So is this making sense to everybody? I hope so. But this is what you're going to see both in the manual for each of these machines, and actually, if you take the front cover off, let's say you're on site without the manual, take the front cover off the machine, we have both these diagrams typically printed on the inside. So this, I don't know if there are any questions about this, and we'll just move on to the next one.
Ted?
Yeah. Hello?
This is I just pulled this off my FTVN, and that's both the diagrams that you showed are on the inside of the front cover of the FDVN, as you said. So they're right here. Unfortunately, these are black and white. They're not nicely colored like yours.
Well, mine came from the manual, so that's why.
See?
But even in black and white, I think you get the idea. The only thing you're really not seeing is you're seeing there's not a whole lot of color here, and but where we are coloring specifically are on these various connections to the board. And for those of you that have worked with those, you know that each color fits in a particular slot, and they're not interchangeable without some field modification.
And now, Ted, with the new boilers, we send all the Molex plugs on all the motherboards. So when they throw the one out that comes with the outdoor sensor, it's already in the boiler.
Exactly.
So we don't have to teach people how to modify the bus terminal or the TT2 terminal plug to fit into the outdoor sensor.
Correct. But
which, as we all know, if you put a black plug into a green hole, the next service guy comes by and says, "Oh, I see the problem. You got the wrong plug in the wrong hole," and he moves it back, and then nothing works again.
Well, and that brings me to something that I've actually thought about for another seminar, but sort of documenting systems, and systems get more and more involved. There's some reason why you might want to document them. I mean, what goes where and the logic behind how you put it all together. I'm sure everybody here has probably been in the business for many, many years, and there are no two systems that are really alike. And I know I've experienced going back to something that I put in, I don't know, 15 years ago, and you'd like to think that you can remember exactly what you did there, but the reality is you really can't. And you waste time sort of deciphering or trying to remember where if you had documented that system and left it there with the paperwork, you could then see the logic of what you were doing, and you'd cut your troubleshooting time down dramatically.
Well, and Ted, you say that, right? So I walk into a house a couple months ago to look at it to replace the boilers. And I walked in and I said, "Hey, I supplied and designed this 30 years ago." And they said, "You're full of shit." And I went over the wall, and the contractor had actually put a holder on the wall, like a literature holder. And I went over and pulled out the little file folder that they had 3-punched everything and put it in. I opened up, and there's my handwriting, and there's all my manually using a pencil. I didn't have Visio back at the time, and
Right.
all my hand-drawn piping and wiring schematics for everything. Go figure.
Yeah.
But we knew where everything was, and it literally made life very easy for the replacing contractor.
Well, and that's the other point. I mean, let's say, and even if it's the same company going back, let's say I put the system in or you put the system in 25 years ago, and now we're sending a tech who works for us there. Well, to him, he might as well be walking into a system that somebody else did or that anybody else did, because he's not going to have that maybe institutional memory that you and I might be able to draw on about that system. And so I think documenting a system, and I really feel like we should probably talk about this more at another time, but
Yep.
there's a real good reason to do that, and particularly if you're doing more than just, something a little more complicated than just a boiler and a circulator and a thermostat. You know what I mean?
Yeah, absolutely.
So anyway, food for thought. Maybe another seminar, but it's
Another seminar coming your way in the near future.
So this is the small TRX. This is the 85 up to the 150C, and it's similar but not exactly the same. So again, the line, the ladder diagram starting again, fighting convention and starting at the bottom, but line on the left, neutral on the right, and the various connections to it. So that junction box where we have up to 4 pumps coming out of it, and then the bus connection to the main board where everything else is connecting. And you can see if you look at these symbols, these are all things that we looked at in that chart a little bit earlier: sensors and pressure switches and so forth. So again, if you get used to those conventions, you're going to see them in drawing after drawing, and not just for us, but really across the whole electrical world. These are very, very common symbols.
Yeah, they're all universal. I mean, you can actually buy a stencil if you wanted to draw this on Visio. You can buy stencils that have all of these in it, or make your own stencils that look just like this.
Right, and there are programs that Visio is a little more universal, where you and I use it, and then we can create drawings. But you can actually buy programs for doing nothing but line drawings or ladder drawings, and all of those symbols are built into them. Here's the sort of the physical, the wiring diagram, if you will, for the small TRX, and very, very similar, but there are a couple of differences between the smaller ones and the larger ones, and you'd have to look at them side by side to really point it out. But there it is. And again, inside the cover, you're going to find both of these. So if you don't have your manual, at least you have a place to turn.
You know, Ted, I'm only laughing because I've been on the phone with tech, and they said, you know, check the line going into XYZ. I think it was the gas valve at the time, and I'm like, well, which one is that? And now after looking at the ladder diagram, which I have to admit that I really haven't studied much, I'm looking at the wire. No, not the next one, the schematic. But you see in the bottom right hand side where it goes, where the gas valve goes to the motherboard, is the last 2 terminals on the right hand side. You
Right.
locate the transformer, you know where it's going, and I'm like, I'm stupid, you know, I'm like, oh my god.
Well, and furthermore, it even tells you what color the wires are.
Yeah, and I'm like, eh.
Right. So
I'm just a plumber, Ted. I'm just a plumber,
yeah,
but you know.
and the tech support is saying, why aren't you looking at the picture, you dummy?
Yeah, exactly.
Yeah.
Yeah,
Yeah,
you
we've
know
all
what they
been
were thinking. Oh yeah, we're paying this guy what?
Yeah, we've all been there. But anyway, this is, and obviously this is very simple, because when you're actually looking at the machine, those wires are running all over the place. They're tied up in a bundle, and you have to actually trace them. So this simplifies that for sure. And that's why I was saying it's not a road map, in that it doesn't show you where everything goes uh, specifically, like if you were looking at one of those maps you were showing earlier, but it does show you how to go about finding it in the machine.
So what you're saying would be like drawing a line from Philadelphia to Boston, and it just says 195, and you know it doesn't go straight. Is that what you're saying?
Pretty much, yeah.
Okay, good. Just you know, fix my analogy that I didn't do well.
Particularly if Boston, let's say, was on the board and Philadelphia was at the gas valve, that's about how close that's
Exactly.
about how,
Exactly.
yeah.
No north and south, no east and west, none of that
No,
shit.
there's none of that. And that's why I was saying it's not a map. It's a pictorial representation. And so you have to, there is, on site, and particularly, you're in a basement, the light's not good and whatever, you've got to trace the wire, but it gives you what you should be looking for. So now we get into a slightly more involved system. We're at the ladder diagram of the TFT, the 85 to 399, all look like this. And now all of a sudden, again, you look sort of in that bottom third of the picture, you can see the transformer. So you know there's 24 volts available in this machine. And this is actually following more of a convention where you're coming in from the top left with the line, top right with the neutral, and how sort of the order of things. And the other thing you'll notice, and for those of you that are familiar with the machine, you'll see at the very top a convenience outlet that stays live even when you shut the machine off at the machine. Notice that it's before the disconnect, and so that's why that power, that convenience outlet, is available for you to plug your, I don't know, your drop light in or something, even when you've got the machine off to do some troubleshooting.
That was the same way on the TFT too, Ted.
Correct. Yep, exactly. And everything that we put a convenience outlet into typically is wired this way. So the convenience outlet will stay live. Obviously not if you've shut a remote disconnect off, but if you've shut the machine off using the disconnect that's in the machine, that outlet stays live. And again, that's this diagram is explaining why that is, which you wouldn't see necessarily in this. You see that the outlet's there, but you don't see that it stays live. And that's the kind of the difference between the two. One is a map and the other is the logic of what's going on. So again, this is what you would see if you pull the cover off a TFTN. This particular one picture came from the from inside the 285 that's hanging on the wall in the training room. I took a scan of it when I was there last week, so I know these are there. Anyway, if there are questions about it, let's talk about it. But I mean, it seems like you're understanding why really there's a necessity when you really want to understand the wiring behind it, why there's a necessity for both of these diagrams and how they work together. The GF, here's an interesting one. There are 3 convenience outlets on the GF 150, and I scratched my head over this one for a little while. I could see the obvious that there was one on either side, but Jason Thompson explained to me what the third one was, and that's how the TRX, that's basically the engine for the GF 150, literally plugs in to what we've added to it to make it into the combi furnace. And that's what the third convenience outlet is for. So you would see 2 of them, one on either side, and then one when you pull the bottom cover off, you would see the third one. And this part, this diagram is only showing what's above and beyond, or in this particular case, below and beyond the TRX that's mounted on the front of it. Because the TRX obviously has its own diagram. So this is showing what we've added to make the combi furnace. And what's going on again down below in terms of how it's actually wired. And as I pointed out before, I mean, you don't see the logic, like you don't see that those convenience outlets are live. All you should, in a diagram like this, all you see is that they're there. And that's why it's important to use both these diagrams when you're trying to do some troubleshooting. Now here we get to the LX. Now, you mentioned something about the LX earlier, Steve, about a thermal fuse. I've seen the door fuses. There's the thermal fuse. It's over on the left-hand side.
Yeah, the
About
thermal fuse on the LX was actually attached to the back of the heat exchanger.
and it's showing up right here in the in the ladder diagram. So that's in series with the door and the air switch. All of these are in that same circuit.
Huh, one big safety circuit.
Yep, yep. So there's a couple. There's the door fuse, the door fuse. Well, there's a fuse for it, but there's the door has to be closed. There's the air switch, and then that thermal fuse, all in this same line here.
Wow.
And it's all in the 24-volt side of all of this business. Obviously, below the transformer is all of this is in the 24-volt side. And then here are the accessible fuses that, you know, the fast-acting blow fuses that are in that machine are up here.
So Ted, you know, it amazes me that we put this diagram on the inside of the door, and how many people have said, my pump B is not working. I said, well, what else isn't working? They said, what do you mean? I said, well, you know, there's one fuse that handles two pumps, and there's one fuse that handles the other pump in the boiler. And here you're showing that pump A and C, which would be your domestic hot water and your central heat circulator, are all running off of one fuse, and of course your others are running
Boiler
off.
pump, and your boiler pump runs on its own.
Yep.
Yep. So yep, and again, it's all about it's about understanding this diagram. Understands that you kind of look at this first and you see where things are connected and how they connect, how they relate to each other, and then you go to the next, and then this actually is kind of your, again, not really a roadmap, but in the sense that it doesn't show everything going where it goes, but it shows how it's all connected. And again, this particular one comes from the manual, but it's inside the door of the unit as well.
So Ted, the question comes up, will the wiring be moving to a CAN bus type system? I don't know what a CAN bus type system is. Do you know? Do you have any idea?
A canned bus?
No, CAN, C-A-N, CAN bus.
CAN bus.
Type system. I don't know what a CAN bus system is.
I don't either.
So
I know what CAN-VAS is. I don't know what CAN bus is.
So I guess the answer to your question, Bill, is we don't know what a CAN bus is, so we don't know, but I'm sure we could find out.
Well, Bill's an engineer, so he should be explaining it to us.
Well, if the typing comes in, I'll let you know, but move along.
Okay. All right, so here, now, I mean, in conclusion, and this I took from an article out of Plumbing and Mechanical a number of years back, but this was a thing by Siegenthaler. So here we're looking at a system, and this kind of ties back into what I was briefly touching on earlier about documenting systems. Here he's drawn a system with a conventional boiler and a heat pump and radiators and so forth. So here you have a system diagram. It's more than just a boiler, but a whole system. But you can still use a ladder diagram to explain how the system relates to each other. And there is the logic of more than just a single machine, but explaining the logic of how everything ties together. And that's where the ladder diagram actually kind of expands on it's not just, it can be used beyond a single piece of equipment, but actually this might be part of, and I know that John was always very big on the idea of documenting systems, but that's where he's illustrating it here. And so this was basically, in conclusion, we look at a system and then we look at the ladder diagram to document.
So, all right, Ted. So I'll read the what a CAN bus is, because I believe that's where we're at right now.
Yeah,
CAN bus wiring is a two-wire network that allows devices to communicate with each other without having a host computer. This allows devices to talk to each other, and really, that's what our room sensors do.
that's what our room sensor does. That's what our external zone does. Where we add 3 zones to a system, it's connected with a bus link, right?
Yep.
So
Yeah.
So I guess that's the depth. The CAN. I didn't realize it was called a CAN bus, but I understand now what it is, and we do utilize it. And in fact, if you, in a sense, maybe this is, if we go back to, here's our bus connection right between the junction box and the main board, right? Everything's going through here. Is that what he's talking about?
I think it's more I think it's more like the thermostats that are talking to the boiler, and the boiler's talking to them without a host, just communicating back and forth.
I got you. Okay. Without having to have an external.
Yep. So.
And right. Well, I think we're utilizing it then already, but maybe not to the extent that Bill can envision.
Yeah, right.
So I think that's really what I have for you guys tonight. I'm going to say thanks and probably go back to Steve's screen here.
That was awesome, Ted.
Thanks for watching the video today. If you'd like to check out more videos, see the link below. Don't forget to like, share, and subscribe to our channel for all the future updates. And also check us out on Facebook, LinkedIn, and Instagram.